Assalamualaikum everyone. My name is Aida Shaira binti Zainal Abidin and my metric number is B0118-126. Today, I would like to present about development of object detection algorithm in the form of deep learning inspection system. The content in chapter 1 is introduction, problem statement, motivation, objective and scope. I would like to intro about inspection system. What is inspection system? Inspection system is a system that used in industry to identify the system state, to reveal the system fault, and to make maintenance decision. The problem statement in this project is many manufacturers still rely on visual and sampling inspection by an operator as opposed to total inspection in real time. Second, develop the technology needed to treat product using minimal cost and times. It is important to measure the product quality in real time and store the measurement in a database. Third, defect inspection system that detect defect in real time and classify defect types is one of the key technologies required for implementing the smart factory. This is the motivation of the project. As you can see at the right side is pie chart graph. The pie chart graph states that 80% of the events are attributed to human error and 20% of the events caused by the equipment failures. When the 80% human error is broken down further, it shows about 30% of the events are caused by the individual mistake, especially in inspection or sorting process. This analysis proves that the industrial required an inspection system that includes with automatic object detection to detect the presence of object instead of rely on human operator to inspect the product. Indirectly, the industry able to reduce the human intervention and able to reach the accuracy or more in quality inspection with automation. The objective in this project is to explore the uses of deep learning method for the purpose of developing an algorithm for object detection. So the objective in this project is to review the previous work of object detection by deep learning method. Second, to design and develop an object detection algorithm in the form of deep learning method. So there are several scopes of this project. First, is to design a system that can inspect condition of screw. Second is the system using Python language to write coding. Convolution neural network was used to classify the object present. Next chapter is chapter 2, which is literature review. Many researchers have shown that the method used can effectively detect the object detections. Below are the methods used by the researcher. So first is convolutional neural network. Second is you only look once, YOLO. Third is faster RCNN, also known as faster region convolution neural network. These are the methods that I will study in the journal article, which is convolutional network, you only look once, YOLO, faster RCNN, which also known as region convolutional neural networks. So how it works for the first method is by enhancing the efficiency of the models. Many layers for CNNs as well as complex structure are implemented. For this purpose, we employ cross library and determine the relationship between the depth of CNN as well as its accuracy. Next, they will select the MNIST dataset in which 60,000 images were chosen for training and 5,000 images for testing purpose. However, to keep the proposed network from becoming more complex, a simpler CNN and eventually more layers were included, thereby determining the performance of a model in each layer. The advantages of this project, for the first method is accuracy in image recognition, higher performance, enhanced accuracy when trained with lots of data, need less time for classification tasks, and affordable. Next method is you only look once, YOLO. The features are extracted layer by layer through the convolutional neural network, and then the object pose is predicted from the output of the convolutional layers at 3 different levels. The pictures are divided into n times n uniform grids to calculate the intersection over the union. The benefit of this method are localization error decrease, average precision for small object improve. It is now better than a faster RCNN. It also has a fast detection. The third method is faster RCNN, which also known as region convolutional neural network. It divided into 4 modules. First module is feature extraction module. Faster RCNN adapt convolution network to encode input image in order to obtain high semantic feature that facilitated subsequent detection without much loss of spatial information. The next module is feature augmentation module. Faster RCNN and some variation of RCNN method introduce multiple feature fusion to generate multi-scale semantic feature. The third module is region extraction module. As described in inference, a lightweight network named RPN or region proposal network is plugged into the multi-scale semantic feature meant to extract regions of interest by using the default inertial bounding boxes. The last module is share head module. All of the ROI features, which have different scale and aspect, are transformed into a fixed size with the help of the convolution layer named ROI, pooling layer, and then some fully connect layers which share parameters are attached to obtain bounding box with the corresponding category information as the final output. The advantages of the project are high accuracy, fast convergence, end-to-end training. Next is Chapter 3 Methodology. Chapter 3 Methodology will include the project flowchart for Final Year Project 1, flowchart of the general process YOLO, YOLOv3 Algorithm, flowchart of image pre-processing, flowchart of new boundary box construction. This is the general flowchart for the Final Year Project 1 and 2. First, we start to understand the title given. Then discuss the keyword finding with supervisor. If the supervisor doesn't agree, we will repeat the process again. If the supervisor agrees, then we proceed to the literature review and journal studies. Then problem statement identification, determine objective and scope. Then we will design and construct the system, consult the findings with supervisor. If the supervisor agrees, we proceed to testing and training the model of the system. Then result and evaluation. After that, report writing. This is the flowchart of YOLOv3 algorithm. The process divided into 3 parts. I will explain the process part by part. The procedure starts by taking an image as an input to YOLOv3 algorithm. YOLOv3 begins by resizing the picture to a new dimension 416 times 416. Neural network of YOLOv3 consists of 106 layers. After resizing the image, it will pass to CNN, which is convolutional neural network. Convolutional neural network takes the image and after processing return tensor which represent coordinates of boundary boxes. Non-max suppression algorithm are filter out the remaining false of the predicted boundary boxes. The box with probability value lower than 0.5 are ignored and filtered out. Pre-trained weight of COCO dataset for detection were used for training. There are 80 different classes in pre-trained weight COCO dataset. This is the next part that I had mentioned earlier, which is image processing. I will explain further about the image pre-processing. The image pre-processing contains 4 steps, which is first, area of interest, image blur, edge detection, and splitting image. First, for the area of interest, the YOLOv3 works quite well in detecting objects on an image. Then propose the algorithm only on the part of the image where YOLOv3 algorithm detected object. The performance will be influenced if the proposed algorithm is applied to whole image. The proposed work saves the cropped image as separate image called as area of interest. This also saves unnecessary computation and helps in enhancing overall speed of algorithm. The next step is image blur, which contains 2 steps, convert to grayscale and Gaussian blur. Blurring will make color transition from one side of the image to other sides. Besides, it will remove noise and outlier pixel from an image. First, the image will convert to grayscale image, and later Gaussian blur has been applied. In proposed work, a Gaussian blur with kernel size 3 times 3 is used. The third step is edge detection. An edge detection algorithm will apply after image blur. Proposed work use state-of-the-art edge detection algorithm, that is canny edge detection algorithm. Despite the edge is still performing quite accurately, the sigma value used in this work is 0.33 and lower. An upper threshold has been calculated using following formula. For the fourth step is splitting image or image partition. One edge has been established. One thing to remember is that the edge is needed for the construction of boundary boxes are much less likely to be found in the center of the picture. The proposed work split the image into 4 sections. Such example, one for each side of the boundary box. Save the image. The width of the top and bottom image is equal to the image actual width, and the height is taken as 25% of the actual image height. The width of the right and left image is 25% of the width of the original image, and the height is taken as the real image original height. This is the flowchart of new boundary box construction, which is for the part 3 of the YOLOv3 algorithm. First, it will split the image, calculate area of rectangle, add all value of pixel in the area, calculate threshold. Calculated threshold must be higher than required threshold. If yes, then it will return to error. If not, it will move by step size back to the calculate area of rectangle. Next, we will go to the chapter 4, which is result. So, this is the result from the previous researcher, and this is my expected result. As you can see in the picture, before apply the YOLOv3 algorithm and after apply the YOLOv3 algorithm, it contains the boundary box, which the blue and red color. It can classify the object accurately, which person seems goes to picture C and D, which is picture D can contain the boundary box which classify the object and detect the object, which is dog, person, and horse. So my expected result is for the next semester, YOLOv3 algorithm able to classify the screw, which is my scope, either in a good condition or in a bad condition. Thank you. So the conclusion and feature work. In conclusion, for FPP1, the objective 1 is achieved. The research will be carried on to achieve objective 2 the next semester. Do an evaluation based on the expected result.